Hey everybody, this is Larry. This is me doing a virtual weekly contest for 57. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. This is a live recording, so this is just a live recording. The explanation will be in the video in itself. So each problem will have an explanation video to itself. So definitely Google for that, check for that, whatever technology it is. Yeah, hit the like button, hit the subscribe button if you'd like to see more, and just to kind of give me support so I could keep going. That's it. Let's get started. Am I good? Yeah, my notebook's here. That's good. Go, go, go. Go, go, go. All right, let's go. Man, this is a lot of reading. What are we returning? Way of order codes of all about it. If valid is code supply is not okay. Well, okay. And we return just a list, right? So, and the list this line in the order. Okay, at least these are alphabetical, so okay. It's a little bit annoying, but okay, fine. It's just busy work, right? So if not A, we continue. Otherwise, if B not in this thing, we also continue. And then if good of C, or if not good of C, we continue. Otherwise, this is good. And then here we have a good function. If C is not in is alpha, I want to say, and not C is numeric, and C is not equal to underscore, then return false. I want to say something like that. And then now we want to say it's possible that I'm going to get this wrong, but we want to sort by the business line and then this code, right? And then now we sort to the business line, and then now we just return x for do x in array, right? Something like that. Okay, maybe not something like that. Oh, this is good. Whoops. No, this is right. It has to be numeric, and if it's not either of these things, and it's not. What is the? Okay, so the good code is wrong. Non-empty. Okay, so I have to check with that anyway. But if C is not alpha, N is not numeric, N is not. Why is this wrong? Is S a huh? Is that, did I return the array by accident? I guess so. No. Why is, oh, that's not a, oh man, what a dumbo. Wow, I am finding new ways to be wrong. Okay, farmer, Alright, very easy, silly mistakes, so let's YOLO submit. Okay, good. Honestly, I wasn't confident about that at all. There's just so many things to read, and when you're trying to rush it, it's not a great thing. But got lucky that time, so that's good. All right, power grid maintenance. You have C power stations. ID 1 to C, 1 index. Okay. Bidirectional cables represented by 2D connections. Connections, okay. Okay. Power grid. If X is online, it resolves the check by itself. X is offline. The check is resolved by the operational station, the smallest ID in the same power grid. Station X goes offline. Okay, I mean, I think I get it. And order matters on the queries, okay. And it's big. I mean, I want to do union fine, but do they all start out online? Okay, so I want to do union fine, but maybe that's fine. If X is offline, so maybe we want to convert offline to have to be a little bit smarter though. No, I mean, you just have to check whether it's offline or not. I'm just being dumb. Okay. I am just being dumb, I think. I think this is pretty straightforward. This is one indexed. Okay, fine. Oh, I have to finish writing the if UA is smaller than UB, then we want parents of UB is equal to UA. Okay, so then that would get us the smallest, and then now it's just about unioning UE, right? And then we do have to do this, and then now for queries, type and X in queries. If type is equal to 1, then we just check if it's power. If power, if power's up X, if power's on, then answer is just X. Right? Else, then answer dot append. You find of X. Wait. Wait, no, that's not right. Why am I struggling with this? It's not right because. Okay, no, that's not right. Because that the root can be terminal. Okay, fine. Okay, so we want something like this, and then we have to do some updating. I can just sort a list, right? Okay, fine. Yeah, it's not that bad, but it's not enough. That's all. Yeah, okay. There are probably better ways to do this, but I'm just lazy, so we'll go with this one. You find I. F of x dot remove x. Right, and then now here we just go f of find of x 0. Should have at least one element, right? Oh no, there should be -1. So yeah, okay. If okay. What is it? -1. Three, 2, 3. Oh, I have to add 1 to it, of course. Back to 1 index. Alright, looks okay. Should be fast enough. YOLO submit. Hopefully no silly mistakes. Oh no! Oh. I guess I should have considered that. Was that not in the input? I guess not. Why am I getting 0 is not in the list and remove? Why? What is this input? Huh? Oh, you could turn on the same thing multiple times. I see. So then you have this thing. That's silly. Okay, fine. There's like this card maybe? I forget. There's one where like only if it exists. I forget what it is. Okay, I guess that one. Is that right? Connections? I guess they don't tell me because I crashed. I think that's right though. Yeah. Silly mistake though. Okay. Silly mistake. I didn't realize you can do it more than once. But okay, fine. Q3. How am I doing on time? Took about 13 minutes. Something like that. Okay, they haven't fixed it yet. Okay. Minimum time for K connected components. Alright. Initially the graph. Okay, so let me reread this. Can be removed at time x. I mean, remove is just the opposite of adding, right? So, I mean, first of all, we want the minimum time. So at the end, I'm just trying to think about this. I mean, I think this is pretty straightforward, but here's the concepts. Let's just find out. It's kind of weird that we have 2 union find problems in a row, though. I guess I should just copy from the other one. But this is so easy, right? Isn't it? Okay, so let's say, so how many edges do we have? And then edges are not related. That's a little bit awkward, but okay. Okay. It's not a binary search, it's just keeping track, but it is definitely very weird. Okay, so then yeah, I don't get it. It's just adding, right? Use up 2, and that's it. I want to know whether, like, is this a tree in the at the end, or can there be cycles? I gotta use the restroom real quick though. Give me a second. Yeah. Alright. I mean, this is just union fine, right? But it can be okay. So you have to remove. A minimum time. So in the beginning, we have a lot of components. So as we move them, I don't think this is that hard, but I'm just struggling to kind of make sure that I have the idea. Okay, so then now after the I mean, removal is just the opposite, right? So then there's something like this. So then now okay, components is equal to n then, right? And then now for if we remove at 3, then I guess yeah, okay. So then now for UV, T and edges, right? We'll say if you find if you find of u is not equal to you find of v, then we union them, and then we components subtract by 1. If components is greater than equal to k, then best is equal to t, and then that's it, right? Can there be a -1? The answer is 0. Why is it 0? Am I understanding this right? I mean, I guess I can just run it. Technically, I think I want to return early, but of course, then it's not going to get any bigger. But Maybe I'm wrong on this one. Best is actually, I guess, just like the last number, which is fine. This is just not right at all. Am I misunderstanding this? Okay, so here you do. No, I'm adding this in a weird order. No, this doesn't feel right. Because you're adding them. But when you're removing them, right? So you add. How do you remove? Remove is not the same as reversing them, I guess. Okay, so let's say we do add order things, right? Maybe it is binary search. I don't know. Binary search would definitely do it, but I just thought maybe it'll be too slow. Let's binary search. I honestly don't know if it's gonna be fast enough, but that's why I'm a little bit worried about it. But yeah. I guess we got actually. It's not an edges, it's E. I think that's where I messed up a little. Oh, maybe it is actually. Lambda x. Basically, we want to go with connect. How many components are there, right? So if T is greater than target, then we break. If components is less than K, then we return false. I want to say. I guess this is just return true. But okay, then now we say. It could be a little tighter bound, but if this is good, then we want to try a later time. Key is okay, still not right. Okay, so if it's infinite time, then we pass order. Maybe this is actually wrong. Because basically, if this is time, and we remove all the things under it. No, this is right. Maybe. Why is 2? Huh. So my time is equal to 1. Okay, so we have 2. A time is equal to 2. We do none of this. This component is equal to n is not right, is it? I think I got the direction wrong because that's when you remove. So it's this equal to maybe. Because that means the time that are smaller, you have to use it. No, that's not right. I mean, maybe it's right, but if it's smaller, we have to use it. So then, if it's greater, then we will remove all of them. Okay, so I think that's right. Maybe this is not mine. Why? Let's do this for a second. If time is greater than target, we skip. Now we want to do it when time is greater than target, right? If the time of this edge greater than target, then we actually, oh no, then we skip it because we can remove it. Okay, so we want to remove all edges, so then we add to this. Yeah, okay, this feels more right though. Maybe not enough. At time 2, you remove these 2 edges, and then now we have 3 components. So where's 4 coming from? Am I misreading this problem? Oh, at edge 4, because you remove that time. Okay. No. Okay, so I think I got this one wrong. So you want to remove all the time be after that. Okay. So you want to remove all the nodes. This is right. And then all the edges afterwards you keep, and then you just count the number of components, right? This is right, so why is it wrong? Alright, let's just take this out, and then now we can do target components. Okay. Oh. Sure. At infinite time, there are 2 components. Yes, that's fair. Oh, maybe it seems like this loop. Okay, so if this is good, then we want to try a smaller time. Silly mistake. I said the wrong thing earlier, so I just got confused. Alright, well, that's not quite right either. So at 0 time, we don't remove. So we have 2 components, right? And that's no. At 0 time, we don't. This is wrong again. Because we have to. No. If it's smaller than target, then we keep, right? So that means that this never happens. So then that means that we do this, right? Am I doing this right? Did I mess up parents? I mean, this is two components, but this is one component, right? So then why is this not here? Okay, so it is here, but then the components, oh no, I'm looking at the wrong column. Okay, one is component. So if it's too small, then it is force, right? Oh, that's because I'm just, yeah. What is my answer? I can't even tell in this UI. 3, 4, 0. Okay, so I guess I fixed it, whatever I did. I just had this here though, didn't I? Maybe I need it here and outside. I think I was just... No, then now it is 0. Oh no, maybe I was just looking at things confusingly. Alright, I don't know if it's fast enough. I think that was the thing that I was worried about. Okay, maybe I shouldn't have. Like, that's why I was trying to do something funky, but I thought it was too slow. And it ended up taking 20 minutes, but I also had to use the restroom, so I don't know. Very tricky problem. Alright, let's see. Q4 minimum moves to reach target and grid. This is so much reading. Alright, they're all big numbers. Let's just pretend that, okay, you started this. M is equal to max, and then you could, it's like some GCD thing, isn't it? What is this property like? So it is something like reverse GCD thing, right? 5, 4. Then you either we move to 4 or half of this maybe. 3, 2. Then you remove either, so it goes to 2, 1. So there's no subtraction, so that means that this has to be bigger. So okay, it goes to 1, 4, and then it just goes to 2, right? 1, 4. Oh, but I thought that it would add 1 twice, but that's not right. Then you just divide it by 2. Or you could also add 1 from 3. But the shortest would be divided by 2, maybe. Okay, so I mean, the idea is there. How do I do this and make sure that it is performant? It's considering that it goes to 10 to the 9. There's some like, it is some GCD thing though. It is very awkward. I don't know that I know how to do this one easily. But for a search, is it going to be fast enough? And what if this is an odd number? I guess if it is an odd number, then it cannot divide by 2, right? Let's try buffer search. I don't know if this is quite, but we can try it. So then now, it has to be the max, so it cannot, a small number cannot be doubled up. So, okay. So I don't know if this is all the case, we have to figure out, but if x is greater than y, then what happens? Then now, either actually, no, it's not, you can't do both, you have to choose. And then, okay, so if y mod 2 is 0, 0, then a possibility, maybe, is equal to y divided by 2. It's either that or, I guess this has to be either x or this, right? So x is the smaller number, and the last move has to be what? Is that true? No, it doesn't have to be. No, it has to be, right? Can you add the smaller number? Yes, but then it becomes the bigger number afterwards. So okay, so it's either x or this, right? Okay, and then yeah, and then now, yeah, xp is the previous number if we move from p, right? So if this is not in this, I could probably write this cleaner, but it's fine for now. I'm just worried about correctness more than timing. Okay, so then now where we move x, let's say you have 3, 5. Now you can move, there's no number for you to go from 3 to, yeah, there's no number, I don't think, because you can't, let's say you have 2, 4, you can add 1 to the smaller number, so it cannot come from 1, 4. So there's no way. Okay, I don't think so. I could be wrong. And then the opposite is true for this one. Okay, and then the only thing that's tricky is if they're the same, right? If they're the same, then if they have to be both. Do they have to be odd or even? Okay, even is easy, but odd. Let's say a 5, 5. Is there a way to get it from 5 anywhere to 5, 5? No, because then the previous max is going to be 5. Is there a way to get from previous even? 4, 4. No, maybe if you go to 4, 4, that's just wrong, right? Because you can't go from like 2, 4, or even 3, 4, 1, 4, 3. One thing is maybe 0. Is there 0? 0 can be a key. So if you start from 0, 4. Okay, well then it has to be 0. So that's actually awkward. I didn't consider 0, so I have to maybe re-examine these things. No, that it can only be 0 if they're the same, then one of them has to be 0 to get to the max, and that's the starting one. Even it could go from 0 all the way to 0, 1. Okay, so then now one of them has to be 0, I think. That's the thing. So then now it's just for okay, and then here we return -1 when possible, because here we want to write if xy is equal to we could probably terminate earlier, but I think that's fine. Q.append as well. Also here, how am I bad? -1, 3, -1. The 3 is good. -1 not so good. Why? For a 5, 4, then the best has to, the previous max has to be 4. Did I mess that? Start with 5, 4, 4, 4. How? I guess I messed it up somewhere. 5, 4, so the x is greater than y. P. Possible is 4. If it, otherwise, oh, this is not right. This is not p minus 4, it's x minus p. Silly boy. That's good enough. Oh, it's a little bit awkward looking. Okay, 2, 3, -1. Is it good though? I think I have to YOLO. I mean, I think it works out. I understand. What's my print statement? Okay, I'm trying to remove that print statement. I think maybe I'm missing some casework, but which is fine. But I feel like it would take me longer to come up with it. That's why. This is 51, but I have -1 is expected. Why do I think it's 51? Let's see. Let's also print out the thing. Okay, it thinks that this is the case, which is true. Subtract 1. No, this is not possible. Okay, I see. So that means that yeah, okay, that means that it else so if it's odd, then if y divided by 2 is greater than p, then we continue. Except for that, we want to multiply 2 on both sides. Is equal fine? Equal is probably fine. think equals fine. Well, it's odd, so it can be equal to, but -1 back here. Now we have to remove the print statement, and hopefully that was the only case that I forgot. Is that 2, 3? Is that right? Yep, okay, I just forgot. Maybe I'm mixing problems in my head. Oh, nice, not bad. I mean, I spent a long time on Q3, but that's it. This one was okay. Like, I probably could have been better, but I think it's a very weird problem, and that is case analysis. Yeah, I don't know that I expected a case analysis problem on Q4, but I guess the key part is knowing it backwards, which I think is not unstraightforward, but all right, let's do a quick retro. Q1, I mean, I'm just reading the thing. Q2, what did I get wrong again? What was my wrong answer? I forgot actually. Oh yeah. The multiple turning off case. Whoops. Q3, I just took a lot of time because I think I was just confused about. Or well, I didn't think you could do binary search, and I was trying to kind of not do binary search. I guess that's the answer. But when I did it, it was fine. This one was pretty straightforward. I just missed this odd case. But yeah. So I guess pretty okay contest. I don't know. It is what it is. A little silly mistake on Q2, but and Q4 even, which maybe I could have thought about it in deeper detail, but I just didn't. I wasn't even confident, honestly, when I submitted, and it got AC, right? So honestly, I don't know how much faster I could have been without the wrong answer. Maybe I should have spotted that, but even if I had spotted that, I would not have been confident, to be frank. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. Have a great rest of the weekend or whatever. I'll see y'all later and take care. Bye bye.